Ever wondered how electricity from a battery or solar panel powers your entire home? It's all thanks to an inverter. In this animated breakdown, we'll show you how it works and why it's so important in our daily lives. An inverter is an electrical device that converts direct current, DC, into alternating current, AC. This is especially important because most household appliances and industrial machines run on AC power, but many power sources like batteries, solar panels, or fuel cells provide DC power. Here's a full, detailed explanation of how an inverter works. But before we begin, let's quickly explain how the DC and AC works. In direct current, DC, electron flows in one direction from the negative to positive terminals. DC voltage and current are typically constant or vary in a predictable manner in one direction. The DC source is generated from solar cells, batteries, and rotors. It is used in portable electronics like phones, laptops, automotive systems, and some renewable energy systems. The DC cannot power our home appliances because it requires a sinusoidal wave signal to be able to operate our home appliances. Wow! In alternating current, electrons flow in one direction, then reverse and flow in the opposite direction, constantly changing direction. AC voltage and current changes direction periodically, often in a sinusoidal pattern. AC is generated by power plants and is the standard for electricity distribution to homes and businesses. It is used in powering household appliances, lighting, and large motors. Now let's get back to the matter at hand. How does the inverter tweak the DC voltage into AC voltage for home use? 1. A battery or solar panel of 12V, 24V, or 48V DC is fed into the inverter as the input source. 2. The inverter uses an oscillator or microcontroller to create a square wave signal. This acts as a timing pattern for switching. 3. High-speed electronic switches, like MOSFETs or IGBTs, are used to turn the DC power on and off rapidly, based on the oscillator signal. These switches flip the current direction to mimic an AC waveform. At first, this switching creates a square wave, voltage switches between plus V and V. Some basic inverters produces a square wave signal as an output, which is not suitable for most electronics. Modern inverters use a technique called pulse width modulation, PWM. It rapidly switches the output on and off with varying widths of pulses. When filtered, this produces a waveform that closely resembles a sine wave. Some inverters produce modified sine wave, a stepped approximation. Pure sine wave, almost identical to grid power. If the inverter needs to step up the voltage, e.g., from 12V DC to 230V AC, it uses a transformer. High-frequency inverters might first convert DC to high-frequency AC, step it up, then rectify and invert it again to get 50-60 Hz AC. Capacitors and inductors are then used to filter the output to smoothen the waveform, reducing noise and protecting devices.